Morning, everyone. Am I audible?
Yes, sir.
Sir, it has been muted, sir.
So, this was the transfer function we have given yesterday. So, we try to determine the roots of the characteristic equation, which are nothing but the poles of the system. And then we equated this denominator to 0. We obtained the roots as SK equal to 1 angle theta. We obtained the roots as SK equal to 1 angle theta. That means what will be S naught equal to 1 angle theta. And S1 equal to 1 angle theta. S2 equal to 1 angle theta. Where theta is equal to, we have written K by plus pi by L plus pi by L. So the equation we wrote yesterday, theta k is equal to k pi by L plus pi by L plus pi by L plus pi. Here, n is nothing but the order of the system. N is the order of the system. So when you know the order of the system, you can determine the roots. So the order means what? Suppose if n is equal to 3, we found that there are 6 roots. S0, S2, S2, yesterday we have seen. Right? So that means corresponding to h of s we have 3 roots. Corresponding to h of minus s we have 3 roots. Okay? When it is equal to 3, we get 6 poles. 3 poles corresponding to this and 3 poles corresponding to this. And then we have seen yesterday that S1 is equal to, sorry, S0 is equal to 1 angle theta naught. That we would have 1 angle 2 pi by 2. Similarly, S1 equal to 1 angle theta naught is equal to 1 angle, I mean, it's like e power j theta k, we wrote it as 1 angle theta k. So 1 angle 2 pi by 3 plus pi by 2 is pi. Then S2 is equal to 1 angle theta 2, which is 1 angle 4 pi by 3. S3 is equal to 1 angle 5 pi by 3. S4 is equal to S4 is equal to 1 angle theta. And then S5 is equal to 1 angle 7 pi by 3, which is nothing but pi by 3. These are the 5 different poles we have determined corresponding to n is equal to 3. Corresponding to n equal to 3, we have written these poles. So that means 6 poles we have. How can I write this one? 1 divided by s minus s naught into s minus s1 into s minus s2. Like that, last one is s minus s2. That way I should write it. Now let me convert these poles, which are in the polar form. Okay, these poles are in the polar form. Let me convert it into Cartesian form. partition forming, so you know very well, right? Perpendicular polar partition. It should be like A plus J before. It should be like A. So when I convert this into polar partition form, what I will do? So it will be cos of 2 pi by 3 plus J sin of 2 pi by 3. Can you tell me the value of that? So that value will be minus 0.5 plus J 0.866. S naught is equal to minus 0.5 plus J 0.866. And then S1 value is 1 angle pi, so this becomes minus 1. S2 will become minus 0.5 minus J 0.866. And then the other one, S3 will be equal to S3 is equal to 1 angle 5 pi by 3. So that would be equal to plus 0.5. So let's get plus 0.5 minus J 0.866. And then S4 is equal to plus 0.5 plus 0.866. This will be one only because S4 value is 1 angle to 1, it becomes 0. And S5 will be equal to plus 0.5 J 0.866. It's not 1 angle 2 pi by 3, it will be minus 0.5 plus J 0.866. Similarly, I am converting all other poles from the polar form to the Cartesian form. So with that, I am able to get the formulas.
Sir, your voice is not audible, sir.
Voice is not audible now. For everyone?
No,
Yes, sir. Right from beginning, it was not audible.
yes, sir. In the first hour, it was audible, sir. Ma'am was not using that headphones, sir.
Tell me. Yeah, one second. What you will tell me? Yeah, repeat it. I mean, you were playing something, right? What was the difficulty? Headphones are?
Sir, ma'am was using another headphone, sir.
That was clear, not this one.
No, sir, it's not clear, sir.
Is this clear now?
Yes, sir.
Is it audible now?
Yes, sir, it's audible, sir.
Can anyone respond?
Yes, sir.
Am I audible now?
Yes, sir.
Okay. Akhil Afroz.
Yes, sir.
Am I audible?
Yes, sir. You are audible, sir.
I am not able to hear anything from your side.
You are audible, sir.
But I was not able to hear anything from your side. Okay. Good. So these are the different poles, whatever we have determined by using this equation, and I have converted all the poles from the polar form to the Cartesian form. So then I would like to write the values of h of s into h of minus s. How can I write that now? So we have totally 6 poles. Therefore, this value h of s into h of minus s will be 1 divided by s minus s naught, s minus s1. Like that I can write s minus s1. So totally 6 poles. Is it not? S0, S1 up to S5 are the different poles. So I am able to write all the 6 poles here. So it is now S minus S0 into S minus S1 and so on. If I substitute these values, I get S minus of minus this value. Minus S0. Minus S0 means this would become plus and this would become minus. Or if you look at this, the real part is negative, imaginary part is positive. So where it will be, the real part is negative and imaginary part is positive. This is your real axis and your imaginary axis. Therefore, this lies in the second part. S1 equal to minus 1 is on the negative real axis. This is real negative, imaginary is also negative in the third quadrant. We have this quantity. When I go to this, I have real part positive, imaginary part negative. The real part positive means this is in the fourth quadrant. In the fourth quadrant, real value is positive, imaginary is negative. The fourth value is 1, that means along the positive real axis. And then this is both real and imaginary components are positive. This is in the first quadrant. Okay. So that means out of the 6 poles, we have 3 poles situated in the left half of the S plane. Another 3 poles are situated in the right half of the S plane. Okay. Now, when we have 3 poles on the left half of the S plane, 3 poles on the right half of the S plane, for the stability of the system, always we require that the poles be situated in the left half of the S plane. Always. No, that you will study again in the control system engineering when you are studying about the stability concepts. For a system to be stable, it is essential that all the poles must lie in the left half of the S plane. Okay? So, these are the poles corresponding to H of S as well as H of minus S. So, corresponding to H of S, we have 3 poles which are situated on the left half of the S plane and 3 poles that are corresponding to H of minus S are situated in the right half of the S plane. Okay? From stability point of view, so 3 poles are situated in left half of the S plane and 3 poles are situated in right half of the S plane. Right half of the S plane. So from stability point of view, I need to consider only the poles situated in the left half of the S-plane. That means I need to consider S0, S0, S1 and S2, which are corresponding to H of S only. Okay. Therefore, H of S is equal to 1 by S minus S0, S minus S1, S minus S0, S minus S1 into S minus S2. So that would be equal to, I will substitute this value, 1 divided by S minus, what is S0 this value? Minus 0.5 plus J 0.866. So this is 1 4. Similarly, the next rule S minus of minus 1. And the third one S minus of minus 0.5 minus J 0.86. So therefore, H of x is equal to 1 divided by, I'll write this term first, S minus of minus 1 is S plus 1. And then I will write this first, S minus of minus becomes S plus 0.5. Minus into plus is minus, minus G 0.866. This is this term. Then I will consider the last term, it becomes S plus 0.5 plus 0.J86. Now, if I consider these things, it's like A minus B into A plus B. A is S plus 0.5. Okay? This whole thing is like A. This thing is like B. Again, this is like A. This is like B. It's like A minus B into A plus B. You get the answer as S plus 1 into S square plus S square with S plus 1. So what will be the value you will get when you simplify these two, when I multiply these two? So this is the transfer function of a third order filter. This is the transfer function of a third order. See, our aim was to determine the transfer function for a third order filter. Okay. So all this we started with our discussion that the cutoff frequency omega c was equal to 1. In the beginning only, we assumed that the cutoff frequency is equal to 1. With cutoff frequency value as 1, we arrived at this value, this transfer function, which is nothing but the transfer function of a low pass filter of order n is equal to 3. Okay, is the transfer function of a low pass filter of order n is equal to 3 and cutoff frequency is equal to 1. Always this may not be the situation. The cutoff frequency may be other than 1. The order may be other than 3, the order could be 4, order could be 5, anything. So this is one procedure we have adopted to determine the transfer function of a normalized filter. What is a normalized filter? I have told you already, normalized filter is one in which the cutoff frequency omega c is equal to 1. And always this situation may not exist in practice. The cutoff frequency omega c may not be 1. In that case, what we should do? What we should do? In that case, S must be replaced with S by the new cutoff frequency. Suppose the cutoff frequency is 2. Wherever S is there, replace that S with S by 2. Suppose if the cutoff frequency is 3, replace S with S by 3. That's one thing. So that is so simple. So this is the transfer function for a cutoff frequency of 1. For any other cutoff frequency, replace S by the new cutoff frequency. S divided by new cutoff frequency. But however, this is the transfer function for n is equal to 3 only. For n is equal to 4, again the values will differ. How to determine the transfer function for n is equal to 4? Once again, I should go for your Sk is equal to 1 angle theta k. What is theta k? Theta k is equal to k pi by n plus pi by 2n plus pi by 2. So that means n value I should consider as 4 in that case. If you are given n is equal to 5, you should consider n is equal to 5. If I have n is equal to 4, I need to find out 4 values of theta k, like in the previous case n is equal to 3. How many values did we determine? 6 values. But even though we determined 6 values, we considered only 3 values because those 3 poles were lying in the left half of the earth. The same way, when n is equal to 4, we get 8 values, but we are supposed to consider only the 4 values. That means it is sufficient for us if we are able to find out 4 values of theta, theta naught, theta 1, theta 2, theta 3. Then once I get the values theta naught, theta 1, theta 2, theta 3, I can find out S naught, S1, S2, S3 in the polar form. Convert those poles from the polar form to the Cartesian form. Once we have it in the Cartesian form, then the transfer function is simply given as 1 divided by S minus S naught into S minus S1 into S minus S2 into S minus S3. Is that procedure clear? So this is the standard, but that means in order to derive the transfer function, in order to determine the transfer function, it is very much essential for us to determine the value of n. We should know the value of n. But in the problem given to you, you will not be given n value. You will be given only the specifications. What are the specifications? You already know about it. There are 4 specifications for the filter. One is Kp, another is Ks, another is omega p, another is omega s. These are the 4 specifications given to you. Okay? So, when you are given 4 specifications, namely Kp, Ks, omega p, omega s, using those specifications only, we should first determine what is the value of n. Once I am able to determine the value of n, then rest of the things can be easily computed. Okay? So now let us see how to determine the value of n. How to determine the value of n. Determination of order of filter, order, that is n of the filter. So you are given the specifications. You know the magnitude response curve of a Butterworth filter. I had told you the magnitude decreases monotonically. So this is the smooth variation in the magnitude. This characteristic is observed in the Butterworth filter. So this is where 0 dB line. That means I will take the magnitude along the vertical axis in decibels. So this is 20 log of h of j omega. Okay, 20 log of h of j omega. We take it along the vertical axis. Frequency along the x. So this value is 0 dB. At omega equal to 0, the frequency is 0. Then this is the passband edge frequency omega p. So for this corresponding to this particular passband edge frequency omega t, the magnitude decreases from here to here. So this is the allowable tolerance in the passband region. Okay, in the passband region, in this passband region, the allowable tolerance is only this much. That means the magnitude should not decrease below this value. Corresponding to this, I represent this value as Kp. Kp is the gain in decibels which a filter can have corresponding to a frequency of omega p. Similarly, I specify another tolerance limit. That limit I call it as Ks. The gain should be less than this at this frequency, which I call it as omega s. What is omega s? Stop band edge frequency. Omega s is the stop band edge frequency. So for you, these are the only specifications given in the problem. Kp, Ks, omega p, omega s. These are the only specifications given. So by using these values, my job is to determine the value of n. What is the order of n? Now here, first of all, let me write down the magnitude equation for this. What is the magnitude equation for the Butterworth filter? We know that h of j omega is equal to 1 divided by 1 plus omega by omega c to the power of 2n is 4 to the power of 1 by 2. This equation already we have written. H of j omega is equal to 1 divided by 1 plus omega by omega c to the power of 2n to the power of 1 by 2. I am not considering a normalized filter. I have a different value of omega c. When omega c is equal to 1, then that type of filter is called as the normalized filter. Now I am not selecting omega c is equal to 1. I will have to determine what would be the omega c in order to get these values of Kp, Ks corresponding to omega p and since we have selected the magnitude along the vertical axis in decibels, it's 20 log of h of j omega. Let us take 20 log of the quantities on both the sides. Okay? Therefore, 20 log of h of j omega is equal to 20 log of this value. Okay? So 20 log of a by b. By the rules of your logarithm, log of a by b is equal to log a minus log b. So it's now 20 log of 1 minus 20 log of this value. 1 plus omega by omega c over 2n. But just before that, let me square that. Just one step before. We'll square that. Squaring on or even the same thing. Okay, you can retain that step. You can retain that step. So 20 log of h of j omega, you can retain that step, is equal to 20 log of 1 minus 20 log of this quantity 1 plus omega by omega c power 2n, right? And this whole value, whole power 1 by. Log 1 is 0, therefore this becomes 20 log 1. 20 log 1 becomes 0. So this is 0. Minus, look at this. This is like log of, suppose you have log of m power n, it becomes n log n. Is it not? Log of m power n can be written as n log of n. So like that I have log of something to the power of 1 by 2, it becomes 1 by 2 log of this value. And already we have minus 20, so minus 20 into 1 by 2 will appear here. Then this is log of 1 plus omega by omega c to the power of 2. This is what? Now, log of h of 0 is equal to 0 minus 20 by 2 becomes minus 10. Log of 1 plus omega by omega c to the power of 2. So that means the magnitude is dependent upon omega value. Magnitude is dependent upon omega value. Let me select omega value as omega p. What do we do? Here I select the value of omega as passband edge frequency, that is omega p. Corresponding to omega p, what is the magnitude? It is kp. It is kp. Corresponding to omega p, magnitude is kp. So I will substitute 20 log of h of j omega as kp and the value of omega as omega. Value of omega as right. At omega equal to omega p, 20 log of h of j omega is equal to kp. At omega equal to omega p, 20 log of h of j omega equal to kp. So you can call this as equation 1. Putting these values in equation 1, we get kp is equal to minus 10 log of 1 plus omega p, because I have substituted omega equal to omega p by omega c to the power. So what I have done here, in place of this I substituted kp, in place of omega I substituted as c. Therefore, minus 10 I will send out outside. Log of 1 plus omega p by omega c to the power 2n is equal to minus kp by 10. This minus 10 I will send to the other side. Therefore, I can write log of 1 plus omega p by omega c to the power of 2n is equal to minus kp by 10. See, suppose if you are given 10 to the power of 2, suppose y is equal to 10 to the power of 2. When I take log, then what it will be? Log of y to the base 10 is equal to log of 10 to the power 2, or simply it becomes 2. 2 log 10, log 10 to the base, this is nothing but 2 log 10 to the base 10. Log 10 to the base 10 is 1, so it becomes simply 2. Okay. So that means y is equal to 10 power 2. How can I relate this one? Log y is equal to log of y to the base 10 is equal to 2. Log of y to the base 10 is equal to 2. Therefore, y is equal to 10 power 2. Is it not? Y is equal to 10 power 2. So when I have an equation of this form, log of y to the base 10 equal to 2, then I can write this one as, if I remove this log symbol, then y is equal to 10 power 2. Same thing, I do it here. So it's like log of something to the base 10. So then how can I write this one? 1 plus omega p by omega c power 2n is equal to 10 to the power of minus kp by 10. Is that okay? Log of something to the base 10 I have is equal to minus kp by 10. If I want to remove this log, then this value is equal to 10 to the power of this value. Okay? And then omega p by omega c power 2n. This one you can bring it to the other side. Omega p by omega c to the power 2n is equal to 10 to the power of minus kp by 10 minus 1. So this you can call it as equation number 2. This you can call it as equation. Now similarly, when I consider this frequency omega s, the magnitude is Ks, is it not? Corresponding to omega s, the magnitude is Ks. So here, in place of omega, I'll substitute omega s. In place of magnitude, I substitute Ks. Okay? So now I can write at omega equal to omega s, 20 log of h of j omega equal to Ks. At omega equal to omega s, 20 log of h of j omega equal to Ks. Substituting these values in equation 1, we get Ks is equal to minus 10 log 1 plus omega s by omega c to the power 2. Is it not? Ks is equal to minus 10 log 1 plus omega s by omega c to the power of 2n. So that means once again I have to simplify this equation as I have done previously, and then what do I get? In place of omega p by omega c power 2n, I get omega s by omega c power 2n. Here 10 power minus kp by 10, instead of that I get 10 power minus ks by 10. So this implies that omega s by omega c to the power 2n is equal to 10 to the power of minus ks by 10 minus. This is equation 3. That means what I have done here, I have tried to simplify this equation in the same way as I have done for the previous equation. So in the similar values. Now here I have omega p, instead of that I get omega s. Here I have kp, instead of that I get ks. But otherwise they are similar. They are similar in all respects. What is our aim? Our aim is to determine the value of n. Our aim is to determine the value of n. So what shall we do then? Let us do some technique so that finally we are left with n value only. We are left with only n value. So let us divide equation 1 by 2. Okay? So dividing equation 1 by 2. Dividing equation 1 by 2. We get dividing equation 1 by 2, we get omega p by omega c to the power 2n divided by omega s by omega c to the power 2n. That must be equal to 10 to the power of minus kp by 10 minus 1 divided by 10 to the power of minus kx by 10 and look at this omega c power 2n and this omega c power 2n, they get cancelled. We are left with omega p by omega s to the power 2n is equal, because this value and this value they get cancelled, equal to 10 to the power of minus kp by 10 minus 1 divided by 10 to the power of minus ks by 10. Now, our aim is to determine the value of n. Our aim is to determine the value of n. So, how can we get the value of n? So, first take the logarithm on both sides. Taking log two n log of omega p by omega s. 2n log of this value. I mean, log of this means what? Log of x power y. So y log x, like that. Okay? 2n log of this value equal to log of 10 to the power of minus kp by 10 minus 1 divided by 10 to the power of minus ks by 10 minus. Okay? And I am interested only in this value. Retain only n on this side, remaining term. N is equal to log of 10 to the power of minus kp by 10 minus 1 divided by 10 to the power of minus ks by 10 minus 1 whole divided by 2 log of omega p by. So look at this. This equation utilizes only 4 values. What are they? Kp, Ks, omega p, omega s. These are the given specifications. So by making use of the given specifications, Kp, Ks, omega p, omega s, we are able to determine the order n. The order n. Okay? And then our job is also to determine the cutoff frequency. Our job is also to determine the cutoff frequency omega c. How to determine the cutoff frequency? So for that, we have written equation 2 as omega p by omega s to the power 2n is equal to, what did we write? 10 to the power of kp by 10 minus 1. This was equation 2. Okay? So you can write here, from equation 2, we have written this. I'm sorry, omega p by omega c. Omega p by omega c was equation 2 is equal to 10 to the power of minus kp by 10 minus 1. Therefore, omega c by omega p power 2n, how much it will be? Just reciprocal. 1 divided by 10 to the power of minus kp by 10 minus 1. 1 divided by 10 to the power of minus kp by 10 minus 1. That is omega c by omega p is equal to what? This is to the power of 2n. So that means if I want to eliminate this one, both sides raise the power 1 by 2n. So this side becomes 1 divided by 10 to the power of minus kp by 10 minus 1 whole to the power of 1 by 2n. In fact, it is 1 to the power of 1 by 2n divided by this to the power of 1 by 2n. 1 to the power of 1 by 2n is 1 only, so I am able to get this value. So I am interested in omega c, therefore omega c equal to omega p divided by 10 to the power of minus kp by 10 minus 1 to the power of 1 by. So here again, I am able to determine the cutoff frequency with the knowledge of two parameters, namely omega p and kp. Omega p and kp, using these two. Or similarly, omega c can also be determined using your equation number 3. So if you are using equation 3, you will get it as omega c equal to omega s divided by 10 to the power of minus ks by 10 minus 1 to the power of 1 by 2. That means omega c can be determined either by using equation 2 or equation 3. Equation 2 is used by knowing the values of kp and omega p, I am able to find out omega c from 2. Or from equation 3, by knowing the values of ks and omega s, I am able to find out omega c. But normally we use this equation so that we can meet the passband requirements accurately. So these are the two formulae you are supposed to remember. So once again go through all these things clearly. By making use of these two formulae, we can determine the order of the filter. So these two formulae are very important. Okay? So we'll stop here.